Rebecca, I want to stress, and I can't stress this enough, that it's very important to have the software have the correct file types. This color theory is challenging on its own, but if you're trying to do it without the correct software, without following kind of the instructions that are presented, it gets much harder, and it doesn't need to be hard. It can be a very simple class. If you take the time to read everything, if you have all the materials, it really doesn't have to be as hard as it can be when other obstacles get in the way, like issues that take away from your time, materials, hardware. All of those things just become obstacles that you don't want to let get in your way. You've already made an investment of time. You're making a financial investment by taking the class. Uh, you want to do things that are going to be the most successful to conclusion of completing the class, rather than have a situation where you may end up taking it again. I think software is going to be the first thing, because if you have, when you have these issues, and we have to talk about software too, we're off track. We're not focusing on color, and it's just going to create another barrier. So hopefully we can get the software resolved. What I've done is I've opened your image, I've copied it already. I'm going to paste it here. Much easier to look at in this situation. And in this, we're going to look at another color wheel as well. With the traditional color wheel, it's just a matter of making an acknowledgement that the color is different than the additive color wheel, that digital colors are not traditional colors. Green and violet, or purple if you prefer, those are the key points. Those are typically the most commonly misidentified. The only area here I direct your attention to is a blue-green. Go look at blue-green paint. Go to like Dick Blick, Utrecht. Find a color that's blue-green, sample it with your hue saturation tool. If you have a Mac, they have a digital color meter as part of it. You can use that to identify it. Either way is fine. When we're looking at the additive and subtractive color wheels, now the lesson explains that these can be the same, because basically the color theory behind both of them is the same. Their relationships as primaries and secondaries are different, and there are differences later, but they require more understanding about your printer, your color management, other things that we don't have to get into yet, because they don't really apply as directly to color theory as the differences between these two systems, and those differences are minimal. When we look at the colors, red is hue 0. That's the top of your color wheel. Color wheel takes a little bit of understanding of geometry, so we're looking at there's 360 degrees in a circle, and that's what the color wheel represents, is that you have red at both 0 and 360. If we type it in as 0, we can look at the RGB values and see that they're 255 red, nothing else. We can go back and type it in as 360, and it's going to be the same. And that's because 0 and 360 is the beginning and the end of the circle. And so then we just work from this corner going clockwise in our increments. And so we basically turn this into a gradation of hue. When we look at yellow, very close here. It's a little bit off, but that's minor. So I'm not concerned about that. The yellow seems like you understand it. When we go to green, we've got two issues. It's a little bit off, and it's a shade. So if we look at the RGB values, we can see that green's there. There's a little bit of red, not a big deal, but the issue here is that it's a shade. Green needs to be at 255. That's your digital green. And so the hue value was very close. 120 is accurate, but that saturation difference makes a change. And we'll see this later on as we look at some of these other ones. In the middle of blue and green, green's hue 120, blue's 240. You split the difference, you get 180. And what we see in the RGB values, and again, I want to stress, I don't recommend using RGB values to identify color. It's very complicated. If you need to learn it later on, you'll figure it out. If you don't need it, then there's no point in us kind of covering it now. But we're looking for equal aspects of green and blue. So you can see that the green value is higher than the blue, and that's what causes it to be more of a green cyan than a cyan in itself. And so that's why it's 167, because 167 is going to be over here. Blue should be 240, and it should be only blue, so you can see that there's some green presented here. When we look at magenta, it should be red and blue equal elements. You can see that there's more red than blue, and so that's why you get more of a red magenta. There's also some green here, which is going to change the saturation. We got to get this basic element correct, because it's listed in week 1, it was listed in week 2 in the discussions. Basically, had to copy it, and then you had to figure out the tertiaries in between. And I think the gradation hue assignment will help you with that, which